Yeah, hello everyone. Myself Maruti. Welcome you all to math video session. So in this video, I have taken a sum from real numbers, that too from real numbers from logarithm topic. Right here, we are going to explain or prove how can we say that log 2 is a rational or irrational. I repeat, we are proving log 2 is it a rational number or irrational number with explanation. And the second one, log 10, is it a rational or irrational, and whatever, we have to give an explanation for that. So let's go for the first one. So what he says, consider given log 2, right? What is given to you? Log 2, very good. So we need to prove whether it is a rational or irrational. So what I am taking, whatever he has given, I like to call it as something like x. I like to take it as x. Let log 2 is equal to x. This is what I have taken. But what is that? So log 2 to the base 10. You have to remember, if there is no base, it's nothing but 10. But I am specifying it. Log 2 to the base 10 is equal to x. I have taken like that. Now, as you all know, it's in the logarithm form. Now, so you have to remember, this is it's in logarithm form. Right, this is in the logarithm form. Let me convert that in exponential form, converting into exponential form. I like to convert in exponential form. You know what's the meaning of exponential form? We need to shift there. Simply see here. The x present here will come here and the 2 present will come here. It becomes log x is equal to 2. This is what he says. If you might have seen, I kept the same 10 here. The base is in the base only. The x went in the place of 2 and the 2 came in the place of x. But here I made that x as straight away the power. Now, what do we have? Log x is equal to 2. Now start thinking. Now let's start thinking. Now it write justification. Right. Just let's go. Justification. We are checking whether it is possible or not. What he says, 10 to the power something is equal to 2. Let's see that. Let's see that. So 10 to the power 1. What is 10 to the power 1? It's nothing but 10. Okay, let's go for 10 to the power 2. Right, what is 10 to the power 2? It's nothing but 100. Okay, we are not getting 2. Or 10 to the power 3. So what we are getting? If the number is increasing, we are not at all getting 2. See here, 10 to the power 1 itself is 10. But what might be that x? For what? 10 to the power x will be 2? No, here simply the number here. The number 10 to the here, the number is increasing. Number is increasing. Never, right? There is no chance of decreasing and it becoming possible. So what we can say, 10 to the power x can never be equal to 2. Right. So what we saw, so 10 to the power x, it cannot be 2, which is contradiction. Which is under contradiction, which is impossible, or contradiction, which is under contradiction. Okay, why? Because 10 to the power x can never be 2, which is against the rules. Therefore, what we can say, therefore, what we have taken, log 2 is irrational. That is what you have to remember. Right, that's the important tricky one. You have to consider this. I like to repeat this. Whatever he has given as log 2. What I am taking, that log 2, and this is in whatever it might be, we have converted, we are equating to x with to the base 10. Okay, now you know it is in the logarithm form. I am converting that into the exponential form. What has happened? I kept the same base. I shifted x there and the 2 here. You got it? Now I am checking out, is it that possible? We are checking out. So you can call it a justification or checking out. 10 to the power 1, 10, 10 to the power 200, 10 to the power 3000. The number is getting increased. We are not getting it as 2. So that's what we said. Here the number is increasing. So 10 to the power of x can never be 2, which is under contradiction. Therefore, we can say log 2 is irrational. In the same way, let's go for the other one. What he says? Given, let's go for the second bit. What's that? Log 100. Okay, let us take that one also x. Let log 100, of course, if there is nothing to the base x, let us take it as x. Okay, now is it in the logarithm form? It's in logarithm form. Right, logarithm form. Okay, now let's convert in the exponential form. Converting into exponential form. Okay, I'm converting in the form of exponential. So you know the logic what I have said. You keep the same base here, yes, and send this one there and that one here. Log x is equal to 100. Okay, now we are checking it out. So 10 to the power of x, can we get it as 100? Let's check it out. Checking. Okay, we can call it as checking. Now 10 to the power 1, how much you got? 10. 10 to the power 2 is equal to 100. Yes, right, it is possible. It is possible. It is not under contradiction. Therefore, log 100 is rational. We can take straight away like that. Why? Because it is possible. 10 to the power 2 can be 100. There is one more method. See here, instead of converting into logarithm exponential form, I am taking straight away from here. Consider, yes, you can prove like this also, log something like that. So 100 is there, 100 to the base 10 is equal to x is there. Means from here we are going. So can I convert it as log 10 square to the base 10 is equal to x? Yes. Can I shift this 2 to the here? That is 2 log 10 to the base 10 is equal to x. What did we do? We have applied the formula. What's that? Log a to the power n is equal to n into log a. This we have converted. Now you know base 10 to the base 10. So 2 into 1 is equal to x. So x is equal to 2. Here we have used the formula. Log a to the base a is equal to 1. Now x is equal to 2. We got a value. So we got a value. We can verify in both the ways to say that one. Therefore, what we can say, log 100 is rational. That's what the proof. We are proving, we are checking here and we are proving in this way that log 100 is a rational number. I repeat, log 100, we took it as x, it's in the logarithm form. I have converted in the exponential form and I checked, it's justified, but still I'm going 100 and as 10 square, 2 brought it to the front. Log 10 to the base 10 is equal to 1, x is equal to 2. We got a value of x. Therefore, we can say log 100 is a rational number. In this channel, I have been placing both math and science videos.